Hello, 1C class. This is my second part of 13.6 because this is a long lesson. I think from now on we probably have to do a lot of like part 1, part 2 because the lesson gets longer now. So the last part I want to do is number 45. Okay, 45 is they give you a function, okay, and then say on C is equal 1 means the level curve of 1 means the first chart, okay. There's at the point 1, 1. They want to find a few things. So number one, they find the gradient, okay. So at 1, 1, so gradient is equal to 6x negative 4y. At the 1, 1, so you change to 1, 1 here, and just equals 6 and negative 4. And then number 2, part B, they want to find the unit normal vector. Find the unit normal vector at P. Well, the unit normal vector, okay, means a vector perpendicular to this level curve here at this point. That will be what? Gradient at that point. So that's same as a gradient. So now we just need to find the, well, we only have the vector, but they said unit normal vector, unit. That is not a unit normal vector, right? How come? Because if you take the length of this vector, the length of vector is equal to 6 squared plus negative 4 squared is equal to 15.2. And which is equal to 2 square root 13. It's not equal to 1. So therefore it's not unit, okay? So now we're going to normalize it. And that's equal to 6 negative 4 divided by 2 square root 13. And I simplify it, it gets out equal to 3 square root 13 and negative 2 square root 13. So that's for part B. Now for part C, I need to erase this part because I need more room for part C. Okay. So make sure if you don't understand it, watch the video a couple more times. And then if you still don't get it, and make sure you bring the question on Wednesday during my office hour. Part C, they said find the tangent line at P. Okay, the tangent line at P now, that is not the same as the gradient. Okay, gradient is a normal to it. The tangent is a what? So let's say this is a curve here. Okay, that's my curve. So this is the tangent line. Okay, tangent. And the gradients are right here. So depend on where they point, where the direction. So let's say it's pointing inside. So gradient is a perpendicular to the tangent. Okay, T. So now we're going to find this one. So this one is just the first derivative, that one. All right? So we're going to, at the level curve 1, okay, because it tells us 1. So that means 3x squared minus 2y squared equal to 1. Okay? We're going to implicitly differentiate this function here. So there'll be, when we run it in 1a, so 6x minus what? 4y and then y prime. Now remember in 1a we learned about that. Implicit differentiation equals 0. Solve for y prime equals 6x over 4y. Put in the 1 and 1, so equals 6 over 4, so equals 3 over 2. Okay, so now this is the slope for the tangent line. So that's my M here, the slope for the tangent line. And now we just put in the formula, y minus 1 at this point equals 3 over 2 x minus 1. And I'm going to solve this. It comes out y is equal to 3 over 2x minus 1 half. Okay, so that's how you do for C. Now for D, the most important part is to put them all together in a graph. Okay, we're going to graph these things together. So expect this in the exam. So you need to graph the gradient, the tangent line on the level curve. Okay, so we are given the graph del G and tangent line on P. So first we need to graph this one first. We want to see what is this. Okay, and you realize that that is actually a what? A hyperbola, but it's not in the standard form. So we put in the standard form first. We put this at the denominator, so that will be 1 over 3, okay, minus y squared 1 over 2. You can see if I flip it, it just get back to that, equal 1. That is a standard form. This one is called the a squared equal to 1/3, b squared is equal to 1/2. And then a just equal 1 over square root 3, b is equal to 1 over square root 2. Now we need to graph this one, okay? So let's do our best. And the x is the first, so that means the x is a transverse axis. So that means the graph gonna open on the x direction, okay? Because x go first. 1 over square root 3, so I use my calculator. 1 over square root 3 comes out as approximately 0.58. And this one approximate to 0.71. So 0.58, so this is a 1 here, this is a negative 1. So 0.58 is about right here, okay? Little bit half, past the half, so it's a little bit here. And then it's a 1 here and 1 here, and then this is a 0.71, so it right here, and then right here. Okay, and then now you're going to draw the asymptote first. Draw the asymptote. Asymptote is across the origin and the two corners of the box. And then your picture going like this. Okay, now your 1 and 1, okay, at the point 1, 1, one's here and there's another one's here, so it's right this. So this is your point P, okay? Point P is a 1 and 1. Okay, now we're gonna draw the they want to draw a couple things. They said draw the gradient. Oh no, they said draw the unit normal vector. Sorry, so draw this one, unit normal vector, not the gradient. So it's a gradient divided by that. I'm sorry. Why do I want to put that? So they want to draw this one. Okay, the unit normal vector. Not del G because it is the F. I was still thinking about the previous problem. So this one we have from the, okay, from B, from part B. Let me go back to find up from part B, yeah. From B, I'm going right here. From B, our del F over this one is equal to 3 square root 13 and negative 2 square root 13. And I'm going to approximate this number so that easy from the graph. It approximates out as 0.83, and then negative 0.56. Oh, not very good. So this is negative 0.56 and negative, this is 0.83. So from here, we're going to draw, now watch here, okay? I'm going to use my purple. You're going to draw, you're going to scale this. Wow. Okay, you're going to scale it. Okay, so you go, there's a 1, right? You use the same scale, so this is a 2 here. So you from here, you're going to go x direction 0.83, so you come to here. So this is about 0.83. And then you're going to go down, negative means you go down a little bit more than half of it. So right here. So that is your, this vector, okay? 0.83, negative 0.56. So that is your, that's your unit normal vector. And then now the tangent line, okay? The tangent line, the function we get from C, okay, from C, we get the tangent function, okay. From C, we have a y equal to 0 to x minus 1/2, okay. And then now you're going to start from here. I'm going to use my red for my tangent line. So I'm going to, maybe I use maybe I use orange. So negative 1/2, this is a 1 here, this is negative 1, so it's right here, okay, negative 1/2. And then you're going to go up 3 and then go 2 on the side. So you go 1, 2, then from here you're going to up 3 unit, so about 1, 2, 3, okay. So connect this one. Okay, so not very good, but without ruler, didn't scale that good. So that, but you get the idea. Okay, so that's my tangent line here. So this line is this. Okay, so that's how you do the problem, and I expect you guys know how to draw the level curve here. So that's a level curve at c equal to 1. X 3x squared minus 2y squared equal to 1. Okay, level curve equal 1. And then you need to know how to draw the gradient and the normal unit vector. So S is come from the gradient. And then the tangent line. So that's read up for lesson 13.6. And then I'm going to do 13.7. Make sure you read the book and watch the video a few times if you need to.